Hello everybody, it is time for us to start going over the topic 8 worksheets. That's the trigonometry chapter, one of my favorites. So let's get started right here with number 10. Which rectangular prism has the longer diagonal, and explain. And they've shown with a dotted line which diagonal they mean. They mean the three-dimensional diagonal through the shape. So what we can do to find that is we can first find the diagonal of one of the bases. All right, and once we find that diagonal of one of the bases for each of these, then we can, I guess that's not probably the one we would want to use in the second one, then we could find, after finding the length of that diagonal, we could use this triangle that we've created as a right triangle. Since the base and the height of this prism are perpendicular to one another, there's a right angle right there. And we can find the diagonal of the three-dimensional shape. So here I have a 3 and a 4, so 3 squared plus 4 squared equals c squared, the hypotenuse. And when we solve the Pythagorean theorem, we get 5 for c. So 5 is the diagonal of the base. And then we're going to use the three-dimensional triangle created by the diagonal of the base, the height, and the dotted line. So 5 squared plus 15 squared equals this c squared, this hypotenuse squared. So that's 25 plus 225 equals c squared, which is going to give me 250 is c squared, which means the square root of 250 is equal to the diagonal of prism P. Then we'll take a look at prism Q. Prism Q has a diagonal in the base that we can find using 4 squared plus 12 squared equals c squared. So that's going to be ending up as the square root of 160 equals c when we solve with the Pythagorean theorem. Once we find that that's the square root of 160, we can use that diagonal base, the height of 9, and the dotted line to find the diagonal of prism Q. So that'll be the square root of 160 squared, remember that's not too hard, plus 9 squared equals c squared. So that's going to give us 160, the square root of 160 squared is 160 plus 81 equals c squared. That's going to be 241 equals c squared, and the square root of both those sides is the square root of 241 equals c. So the longer diagonal belongs to prism P with the square root of 250. So prism P has the longer diagonal. All right. Let's take a look at number 11. Dakota is asked to find the length of EF. What is her error? Dakota says there's not enough information because you either need to know the length of side DF or one of the other angle measures. However, we can do this because we see that we have a right triangle, and this right triangle is isosceles, which means that it's a 45, 45, 90 right triangle, which has a pattern. So let's write that. You know that this is a 45, 45, 90 right triangle because the legs are congruent. Because the legs are congruent. So what we can say is we can use the 45, 45, 90 rule. We can say that x root 20, not x root 21, x root 2 equals 21. And then we can find that that side DF or EF is going to be this divided by the square root of 2. Divided by the square root of 2. So that means that 21 over root 2 equals x, which is somewhere around 14.85. All right. Number 14, write an equation that represents the relationship between JK, side JK, and side KL. So this is a 30, 60, 90 triangle, which means that if we're starting at JK, we're starting right here, we're going to say, all right, how does JK compare to KL? And so I can go either way on those. I can start at JK and turn it into KL, or I can start at KL and turn it into JK. Both would work. If I started at KL, I would say, well, KL is the hypotenuse, and I know in my triangles here, I know that if the short side is x, the hypotenuse is 2x, and the long side is x root 3. So I could take KL, which is 2x, divide it by 2, so that it's just the short side x, and multiply it by the square root of 3. That would give me KJ. Similarly, if I wanted to go backwards, I could start with KJ, which is x root 3, divide it by the square root of 3, gives me back my x side, JL, multiply that by 2, that's going to give me KL, the hypotenuse. Either way works for that question. Next, find the unknown side length of each triangle just using the Pythagorean theorem. So we've got the hypotenuse. So 9 squared plus x squared equals 5 root 10 squared. So 81 plus x squared equals 5 squared is 25. The square root of 10 squared is 10, so that's 25 times 10. 81 plus x squared equals 250. Then solve. So x squared equals 169. And then we'll take the square root of both sides and find out that x equals 13. So the missing side, RS, is 13 units. Number 20, find the side lengths of each triangle, and we've got some special right triangles here. So we've got this 45, 45, 90 right triangle where we know the hypotenuse. So I know that 12 is on the side that is usually x root 2, because I know I've got x for the short sides and x root 2 for the long side. So I know 12 is equal to the x root 2 side. So I can go ahead and I can divide both sides by the square root of 2. And I get 12 over the square root of 2. Now, I can't use 12 over the square root of 2 because 12 over the square root of 2 has a radical in the denominator. So I need to rationalize this fraction by multiplying by root 2 over root 2. And when I do that, that's going to give me 12 root 2 over 2. And 12 root 2 over 2 reduces because 12 over 2 reduces. So that becomes 6 root 2. So the side lengths of each triangle that are missing are JG, my initials, equals 6 root 2. And HJ equals 6 root 2 as well. Both of those missing sides are 6 root 2. Oh, come on, that's not going to be a rectangle for me. Try again. All right. Number 21, what are XY and YZ? So we've got a 30, 60, 90 triangle here. Fairly straightforward because we have the hypotenuse. This side is 2x, which means XY is half of that, or 9. And YZ is that small side x root 3, so 9 root 3 there. Number 22, what is QS? So we got to kind of think about what is going on here. I know that this side is 10 units long. And it's a 30, 60, 90 right triangle. The other one is a 45, 45, 90 right triangle. So if there is a 60, 30, 90 right triangle with a long leg of 10, that 10 is in the x root 3 position. So we're going to divide both sides by the square root of 3. And so we find that x is actually equal to 10 over root 3. But of course, we need to rationalize the denominator because that doesn't work. So we will multiply that by root 3 over root 3. And that is going to give us 10 root 3 over 3. So RT, the short side, is 10 root 3 over 3. 10 root 3 over 3. And that means that TS, because this is a 45, 45, 90 right triangle, is also 10 root 3 over 3. So the total for QS is an irrational number. We have a rational piece plus an irrational piece. We can't add those together, so we can just set them next to each other. 10 plus 10 root 3 over 3. If you were to find that number to a decimal approximation, let me tell you what that would be here. Whatever. No, not whatever. I want this to be a rectangle. Your math teacher can't draw a rectangle. That's the one that worked? Okay. So QS is 10 root 3 over 3 plus 10, or QS, if we wanted to make it a decimal approximation, is around 15.77. All right. Next, Esteban wants marble bookends cut at a 60-degree angle as shown. If Esteban wants his bookends to be between 7.5 and 8 inches tall, what length D should the marble cutter make the base of the bookends? Explain. So there are two possibilities there. We could have bookends that are 7.5 inches tall, and we could have bookends that are 8 inches tall. So there's a range there. And in that range, either way, that side, 7.5 or 8, is the long side of a 30, 60, 90 triangle. So either way, it is the x root 3 side. So either, in this case, they use D instead of x. Either D root 3 equals 7.5 up to D root 3 equals 8. Those are our ranges. That height needs to be between 7.5 and 8. So all we need to do is solve and figure out what the D value needs to be. So for these, we're going to divide them by the square root of 3. And when we get that, we can use a decimal approximation if we wanted to, because there's already decimals in this problem. And we would find that D is approximately 4.33. 4.33. And the other side, if we divide both sides by the square root of 3, we get D is equal to 8 over the square root of 3, which is approximately, let's see, D equals approximately 4.62. So our range of bases is between 4.33 and 4.62. Between 4.33 and 4.62. All right. Number 24. Sarah finds an antique dinner bell that appears to be in the shape of an isosceles right triangle, but the only measurement given is the longest side. Sarah wants to display the bell and wand in a 5.5 inch by 7.5 inch picture frame. Assuming that the bell is an isosceles right triangle, can Sarah display the bell and wand within the frame? Explain. Now, this is a dumb question. This is a dumb question because why can't she just put these two things in the picture frame and figure it out? I don't know, but we can use math to figure it out regardless. So if that dinner bell is a 7-inch length and it is an isosceles right triangle, then that means that there's a right angle right here. It also means that we can figure out the lengths of the other two sides, because we can say that if this side is 7, then we can find this side and this side, because 7 is going to be equal to x root 2. And we can find this x root 2 a few different ways. You can use algebra. You can use that idea that since this is an isosceles right triangle, I could put a dividing line down the middle And that dividing line down the middle would create another isosceles right triangle because of similar triangles. And that base, which is 7, could be split into 3.5 and 3.5. And if there's a right triangle with its short sides of 3.5 and 3.5, then its hypotenuse, which happens to be the slanty side of the dinner bell, is 3.5 root 2. All right? So then, let's see, assuming she wants this bell and wand within the frame, we can, of course, prove to ourselves, if we wanted to, that this is going to be a, what do you even call that? My goodness, my brain is broken. An isosceles triangle with this triangle right here. We could use the right triangle theorem to figure that out. The Pythagorean theorem, we could say 3.5 squared plus x squared equals 3.5 root 2 squared. And when we figured that out and solved, we would find that x equals 3.5. So the other side that we're missing also equals 3.5. So we found out that the height of this dinner bell is 3.5 units. She wants to figure out if the combined height is going to fit in the frame. Well, 3.5 plus 1.5 of space, that's 5 units. So the height is 5 inches. We'll say 3.5 plus 1.5 equals 5 inches. And our frame is 5.5 inches tall. So yes, it can fit in the frame. Yes, it can fit in the frame. All right, let's see next. Number 26, match each set of triangle lengths with the best description of a triangle. So if a triangle has square root of 2, square root of 2, and square root of 3, that's one of them. The other ones might be easier to pick out. Like number 3 is easy. 8, 8, and 8 root 2 is C. That's a 45, 45, 90 right triangle. Number 4 is easy to pick out because that has 11 and 22, which is double of 11, and 11 root 3. So that's B, a 30, 60, 90 right triangle. And then for these other ones, you just need to use the Pythagorean theorem to see if a right triangle exists. So does the square root of 2 plus the square root of 2 equal the square root of 3 squared? Hint, it does not, so that is D. But 5 squared plus 3 root 2 squared does equal 43 squared. So that is a right triangle, even though it's not one of the special ones. Number 27, what is GJ? GJ would be the side length of a 30, 60, 90 triangle that is half the hypotenuse. So all we need to do is take 37.4 and cut it in half, which gives us 18.7. And finally, number 28, Emma designed 2 triangular sails for a boat. What is the area of sail A and what is the area of sail B? So for A, the area of sail A, if that hypotenuse is 12 and it's a 45, 45, 90 triangle, we can work backwards with some of our theorems and say that means that each of these 2 sides must be 6 root 2 and 6 root 2, right? Half the hypotenuse times the square root of 2. So the base times height divided by 2 gives us 6 root 2 times 6 root 2 over 2, which is 36 times the square root of 2 squared, which is 2 over 2. 36 times 2 over 2 is 36. So the area of triangle A is 36. And then for triangle B, we have a 30, 60, 90 triangle where we know the medium side. So in order to find the small side, we need to take 8.7 and divide it by the square root of 3 because 8.7 is x root 3. 8.7 divided by the square root of 3 is roughly 5.02. So 5.02 is going to be the base length. So we'll do base 5.02 times height, 8.7, divided by 2, and we'll get around 21.84 units squared, meters squared. There we go. If you've got any questions about this section, do not hesitate to ask, and I will see you another day.